Today's topic is graphing in vertex and intercept form. I-can statement is graph in vertex and intercept form. We have two vocab words, vertex form and intercept form. We're going to go over what they look like and all the parts you can solve for them. Vertex form is y equals a times x minus h squared plus k. A, h, and k are going to be numbers, and what they represent will help you find certain key parts. One of the key parts you can find is similar to standard form, is the extrema. We can find that by using A. A is in the same place as it was in standard form, and it says the same thing. It will give you the maximum or the minimum. It's opposite of what you would think. If it's a maximum, it's a negative A, minimum, positive. Now, from its name, the vertex, you can find the vertex of it. The vertex would be HK. If you have the vertex, you also have the axis of symmetry because they share the same x value. So the axis of symmetry is going to be x equals h. We like the vertex form because everything's given to you, no solving needed. Intercept form is y equals a times x minus p times x minus q. A lot of similar things. Again, the extrema, you use a. This is the same on every form of quadratics. If it's negative, you have a max. Positive, you have a min. Now, intercept form is because we can solve for the x-intercepts. The x-intercepts are going to be p, 0, q, 0. Now we can use the intercepts to help us solve for vertex and axis of symmetry. The axis of symmetry has a little formula similar to that negative b over 2a, but instead it is p plus q divided by 2. And similar to standard form, for its vertex, you can use the axis of symmetry, p plus q divided by 2 for the x value. To find the y value, plug in. We're going to go over these two forms. In example 1, we're going to talk about vertex form. We're going to find the vertex, axis symmetry, and the min-max. The easiest one is the extrema. If you look at A, it's a negative 1/2. Negative, think opposite, so it's going to give us a maximum. The vertex, we need to look very carefully at how the form's written. If you remember, vertex is a times x minus h squared plus k. Now, the vertex would be the value of h and then k. The k is pretty straightforward. However, the h, it's inside of a parenthesis, and it's written as x minus h. But when you take the value of h, you're not taking the minus or the negative, it's just h. So our form is written as x minus 5, matching up with the x minus h. So we can take 5 as our h and 4 as our k. If you have the axis symmetry, if you have the vertex, you also have the axis symmetry. It's just the x value. Okay, we're going to do another vertex form. We're going to find the three things and graph it. So make sure you have a graphing calculator. A is 2, positive, so think opposite. We have a minimum value. The vertex. This one's different from last time. Let's see how. The form is a times x minus h squared plus k. It's written as x minus h. However, our example is x plus 5. We can rewrite x plus 5 as x minus a negative 5. Remember, minusing a negative means plus. So h is now going to be a negative 5. If you think anything inside the parentheses, switch the signs. Since it was a plus 5, we're going to write it as a negative 5 for h The k stays what it is, -1. Axis of symmetry, since you have the vertex, you have the axis of symmetry. Make sure you write it correctly. X equals the x value, -5. Now I found all three things, but to graph I need to have at least 5 points, and I only have 1 point. The vertex at being -5, -1. I really need to use my graphing calculator in the table to find all the other values. So grab your calculator, go to y equals, type the equation in, push graph, take a look at the graph, see if it looks correctly, it is a minimum, and then go to the table. Now we can check our point. I can see if -5, -1 is point. If I scroll up, I can see that at where x is -5, y is -1. We're good. I need to plot 4 more points. I can do the symmetrical points, so one on one side, one on the other, and get done. So my next point I'm going to graph is -4, +1. Its symmetrical point is on the other side of the vertex, -6, 1. 3 points, I need 2 more. The next point I can graph is -3, 7. And that symmetrical point would be -7, 7. Once you have 5 points, do a gentle U curve, arrows on the end. Example 3, we're going to go over intercept form, which can also be called factor form. We're going to call it intercept form. Factor form will come up more later. Let's start with the easy stuff, extrema. There's not an A, it's an invisible 1, but it's a +1, so that gives us a minimum. And then the x-intercepts, those are what we're trying to find, come from P and Q. If you remember, the form is x minus P, x minus Q. Now, similar to vertex form, we have x minus a number, x minus a number. So we might have to switch the signs. On the first one, x minus 1 matches up, so P is 1. My first intercept's 1, 0. However, on the second one, it's written as x plus 2, which I can rewrite as minusing a -2. So Q is a -2. We have the two x-intercepts. We can use those to find the axis of symmetry. We can do this with a new little formula, x equals P plus Q divided by 2. So let's plug in. We said P was 1 and Q was -2. Well, 1 plus a -2, that's -1 over 2. So my axis of symmetry is x equals -1/2. If you have the axis of symmetry, you have the x value of the vertex. They go hand in hand. To find the y value, I'm going to plug in. So y equals, instead of x, -1/2 minus 1. Instead of x, -1/2 plus 2. If we go through and solve, that gives us -1 and 1/2 times +1 and 1/2. If you times those two together, you get that the vertex is at -2.25, or you can always write it as a fraction as -2 and 1/4. They mean the exact same thing. Last example, let's do intercept form again, add the graphing to it. So let's find the key parts. Extrema, A is positive, so we have a minimum. X-intercepts. X minus 3 matches what P would be, so it's 3, 0. X minus Q, that doesn't match, so I can rewrite it as minusing a -1, so -1, 0. Axis of symmetry. we'll use that new little formula we have. X equals P plus Q divided by 2. So P was 3 plus Q is negative 1 divided by 2. 3 minus 1 is 2 divided by 2. Axis symmetry is X equals 1. Vertex, we're halfway there. 1 is for the X value. To find the Y value, we're going to plug in. So Y equals 1/2. X, we're going to plug in 1, minus 3. X, plug in 1, plus 1. If I go through and solve this, I will end up that the X value is at a negative 2. Now we need a graph. Let's plot the points we do have. We have a vertex at 1, negative 2. And we have two x-intercepts at negative 1, 0, and 3, 0. As you can see, those 2 points are symmetrical around the axis symmetry. So we know we're doing a good job. But I still need 2 more points. Use your graphing calculator. Go to y equals, plug in the equation. Go to graph, see what the general look is, and then go to the table. You can always check the points we've solved. Does it have the point 1, negative 2, 3, 0, and negative 1, 0? If it does, you know you're doing a good job. You need to plot one more set of points. You have a couple of options. I'm going to use the option of 5, 6, and negative 3, 6. Now I can see the general look of my parabola. U-shape with arrows. So let's recap. Can you graph in both of the forms? Can you find all the key parts for both of the forms? If you need to, go back and watch the examples, watch the additional videos, or come in for help.